Hello guys, welcome to another maths class. Physics class, and we would continue from where we stopped in our last class on waves. Today we are going to be speaking on mathematical representation of waves. So without further ado, let's just get straight into business. First off, if a wave moves sinusoidally, the word sinusoidal means sine. If the wave moves like a sine wave, like this, how do we mathematically represent this kind of wave? For sinusoidal waves, you could mathematically represent it thinking of something first, the origin, where the wave starts from. Should the wave start from this particular point here, x is equals to 0, y is equals to 0, like this wave you have on the screen, then you could mathematically represent this wave as y is equals to a sine kx, and a here represents amplitude, k represents wave number. And what does wave number mean? It means how many wavelengths can be completed in one cycle of revolution. One cycle of revolution is 360 degrees or 2 pi radian. So how many wavelengths can we see in one cycle of revolution? Therefore, we could say k is equals to 2 pi radian over wavelengths. It's trying to tell us how many wavelengths do we have in 2 pi radian. Does that make sense? What else? Kx together becomes something called the phase angle or the phase difference. So in case you come across a question that says find the phase angle or find the phase difference, you're telling you to find kx. Yeah, let's go back to our equation. We said for a wave that starts at the origin, x is equals to 0, y is equals to 0, we can mathematically represent the wave as a sine kx. But now, what if this wave is progressive? Progressive meaning the wave is moving either to the left or to the right. How do we mathematically account for this progressive wave? Now, for the wave to move, it means it has been shifted either to the left or to the right. Let me see if I could try and move this wave. Let me see if I could try and move this wave. Coming. Coming my. Let me see. Now it means the wave was either shifted forward like this or was shifted backward like this. That's what it means for you to have a progressive wave. Look at it. The wave is moving forward. This is a progressive wave, moving out or moving in. Are we together? So let's say the wave starts from, let's say, somewhere like here. Let's keep it like this. What did you notice? There have been something called a phase shift. They've shifted, the x-axis of the wave. And if there have been a phase shift in a wave, to account for it, you just need to add plus phi in the equation. The phi here represents phase shift. It has been shifted, by phi units to either the left or to the right. Are we together? So when we have a progressive wave, this is the equation that accounts for a progressive wave. Now, when there is no phase shift, which means when the wave starts at the origin, then phi will be equals to 0. Are we together? Which takes us back to a sine kx. But that is fine. Yeah, this is not the form of equation you'll be seeing in most of your textbooks. The equation you'll be seeing in most of your textbooks will go like this. Y is equals to A sine kx plus vt, like this. But how did we get to this particular equation? Let's go. Now, like I said, for a progressive wave, if it has a phase shift like the one we have on the screen, you just have to add phi, which is telling you there's a phase shift on the wave. How do we account for the motion of this phase shift? Now, do something for me. When there was no phase shift, the equation of the wave was A sine kx. And what is the starting point on the x-axis for this wave? Equate this kx to be equals to 0, and I'm going to be having the starting point to be 0, right? But for this kind of wave, this particular one, what will be the starting point? It is going to be kx plus phi is equals to 0, which means our starting point is going to be negative phi over k. I'll go again. To get the starting point, you just need to equate the angle, the angle that has the sign to be equals to 0. And the angle here is kx plus phi. So I'm going to be having kx plus phi is equals to 0, which means our wave starts at negative phi over k. Now, for our wave to move from 0 to negative phi over k, it means this x, which is our starting point, would move backwards. Why is it backwards? Look at it. If this is 0, and let's just call any point negative phi over k. Let's say this point, negative phi over k. For the wave to move from 0 to that particular point, it's going to be moving a particular distance. Did you understand it? So, because the wave is moving a particular distance, the x changes from 0 to y is equals to A sine k. The x goes from whatever it is minus this particular distance removed. Does that make sense? All right. You can accept with me that distance is a product of velocity and time, which means our equation now becomes A sine k into x minus velocity times time. Are we together? And that is how they got this equation, A sine kx minus vt. So do me a favor, write this particular answer we've gotten as equation of progressive wave. Put it inside your formula notes, where you just write only formula. A sine k into bracket x minus vt. And if you check your textbooks, yeah, we have that formula here. See it here. A sine k into bracket x minus vt. I know you are saying, but I'm saying 2 pi over lambda. Yes, sir. How did we have k? Don't forget, recall that k, see it here, the wave number is equals to 2 pi over what? Lambda. So it is exactly the same thing. I could just put 2 pi over lambda in place of k. Are we together? I hope you understand, why both of these equations are exactly the same thing. Yeah. I also need to establish something for you. A wave could be a positive sine wave or a negative sine wave. A negative sine wave meaning, okay, let me start from a positive sine wave. A positive sine wave means it is moving up before it moves down. It goes to the positive y before going to the negative y. This is a positive sine wave. And this is a negative sine wave. It goes down before it goes up. Do you understand this? Now, if a wave goes up before it goes down, then the equation is going to be A sine k into brackets x. What did I write plus? It's supposed to be minus. X, see this formula here, X minus VT. X minus VT. But what if the wave is going in the other direction? It means it is going down before it goes up. And I'm going to be having A sine K into bracket VT minus X. Do you understand it? Moving out, upwards before downwards, the oscillation. This is moving downwards before upward, the oscillation. So this is the negative of this. Is that clear? If you check your textbook again, you see that they might give you more than one equation, like this textbook, where they give us 1, 2, 3, 4, 5 equations. Is it necessary you cram all the equations? The answer is no. You just need to cram maybe 1 or 2, and every other equation can be gotten from these two. Daniel, don't go anywhere yet. All right, so let's go on to how did they get these other equations that we have here. Yeah, it's very, very easy. Let's even write it the way they wrote it here. If you substitute for K, we can be saying A sine, don't forget K, is equals to 2 pi over lambda. Check your formula book, you will see it. I will say 2 pi over lambda into bracket X minus VT. Although I prefer students using this form in exam as it simplifies the whole situation for them. Now, how did they get this second equation? Yeah. To get this second equation whereby frequency was involved, all they did was, let's go on, we said A sine 2 pi over lambda, which is K, into bracket X minus VT. Open this bracket with only lambda. With what? Only lambda, and I'm going to be having A sine 2 pi into bracket X over lambda minus VT over lambda. Are we good? Yeah, where are we going to? If you remember our last class, we said there's a relationship between lambda V and F. We said V is equals to lambda F. You do remember this equation? Therefore, F must be equals to V over lambda. Are we together? And what did you notice here? We have V over lambda at this particular point, which means this equation can become A sine 2 pi into bracket X over lambda minus F, which is now V over lambda T. And we have the equation too. Let me write this properly. A sine 2 pi into bracket X over lambda minus Ft. Are we together? And if the wave is moving in the opposite direction, that is, if it is going negative first, this equation would now become A sine 2 pi into bracket Ft minus X over lambda. Trust me, if you can cram only these two equations, this and this, you are good to go for mathematical representation of waves. Write these two formula down in your formula book. A sine K into bracket X minus VT and A sine 2 pi into bracket X minus lambda minus Ft. And you're good to go. Let's have some examples on that though. Sorry. See this question. They said example 16. A progressive wave has a wavelength of 50 centimeters. So let's take that down. They say the progressive wave has a wavelength of 50 centimeters, which is something that's saying 0.5 meters. Yeah. And they said it has, they said calculate the phase difference. Did you remember what phase difference is? Yes. Recall that Kx is the same thing as saying phase angle or phase difference. I said that, isn't it? So we are told to find kx. Calculate the phase difference if the waves are a distance of 20 centimeters apart. Distance x is 20 centimeters apart. Yeah, don't forget, if we are looking for kx, recall that k, which is the wave number, is 2 pi over lambda. Did you remember this? Yeah. Therefore, kx is going to be 2 pi over lambda multiplied by what? X. And we have 2 times pi times, what is our x? 0.2 meters over, what is our lambda? 0.5 meters. Pull up your calculator and let's calculate. So we are going to be having 2 times 0.2 divided by 0.5, and we have 0.8. So we have 0.8 pi. 0.8 in fraction is the same thing as saying 4 over 5 pi. So this is our phase angle, our phase difference. Do we have any options like that? If you look at it, they got 4 over 5 pi. And the next question, they said the distance between 2 points P and Q along a wave is 0.05. So they are giving us the x to be 0.05. What else do we have? They said if the wavelength of the wave is 0.1, as lambda is equals to 0.1. What else? Determine the phase angle between P and Q. Recall, phase angle is kx, right? And the same thing as saying 2 pi over lambda times x, which we have 2 times pi times 0.1 over x is 0.05 over 0.1. Here, pull up your calculator, and we're going to be having 2 times 0.05 divided by 0.1, and our final answer is equals to 1 times pi, which is equals to pi. 1 pi, which is something that's saying pi, and that's our final answer, pi radian. And if you check, what was their solution? Oh shit, we've gone really far by mistake. Yeah, this is it. Look at it. The answer is pi. That was their final answer. Now they give us another example. They said a wave has an amplitude of 4 meters. Amplitude of this wave is 4 meters, and an angular speed of 1 over 3 pi radian per second. 1 over 3 pi radian per second. Angular speed. Angular speed is represented with the symbol omega. Whenever you see omega, omega means angular speed, and they said it is 1 over 3 pi radian per second. Are you done? All right. What else were we told? It said the displacement y of the wave is giving us. So we are told to find y. And don't forget, y is equals to a sine kx minus vt. Right? Which can also be given in the form of y is equals to a sine 2 pi into brackets kx over lambda minus ft. isn't it? But the problem is, where did omega come from? Pay attention to this. Omega, which is angular velocity, is equals to angular displacement theta over time. One complete revolution is something as saying 2 pi radians divided by time. So whenever we see 2 pi over time, that is angular velocity. Is that clear? So how can we get 2 pi over time in this situation, right? We could just do how do we get 2 pi over time? Okay, let's open the bracket with 2 pi, and I'm going to be having a sine open bracket 2 pi kx over lambda. Watch this, minus 2 pi ft. Are we together? But yet we don't still have omega in this equation. How do we now get to omega? Recall that frequency is equals to 1 over period, isn't it? So I'll replace frequency with 1 over period, and I'm going to be having a sine 2 pi over, oh sorry, why am I still putting k again when I put 2 pi over lambda? So I'm going to be having 2 pi x, not just, because k is 2 pi over lambda, isn't it? 2 pi over lambda is k. So 2 pi x over lambda minus 2 pi over t multiplied by time. Are we together? Now this 2 pi over t is same thing as saying omega. Have you seen it? So we're going to be having a sine 2 pi x over lambda minus omega t. And this is the formula that allows us to factor in omega into the equation. What were we given? We are given a to be 4. Two pi is 2 pi. What else were we given? They gave us they only give us a and they gave us omega. So they didn't give us x, neither did they give us lambda. So we're going to be having 2 pi x over lambda minus omega t. What is omega? 1 over 3 pi. 1 over 3 pi times time. Is there any other thing we could do? Yeah, I think I could factor out pi in this equation. If I factor out pi, I'm going to be having 4 sine pi into bracket 2x over lambda minus t over 3. All right, so this is the way I'm going to leave, my own answer. This is the way I'm going to leave my answer. Let's go to the next question. Now they said a traveling wave moving from left to right has an amplitude of 0.15 meters. So they give us amplitude of 0.15. What else was given? A frequency of 550 hertz. 550 hertz. And they said a wavelength of 0.01, that's lambda, 0.01. They said which equation describes the wave? All right, so how do we solve this question? We need to pay attention to one important detail. They said the wave was moving from left to right. So because the wave was already moving, we have to factor in motion. And the formula we are going to be using here is going to be y is equals to a sine 2 K open bracket x minus vt. Did you remember this formula? The first progressive wave equation I gave you guys. This is it. So let's try and use that formula with what we are given. My A is 0.15 sine k, and we don't know x minus. Oh, there are many things that we're not given. V, how did we get vt? Now pay attention to this very, very carefully. How does f come into the picture? Now look at it. K is something that's saying 2 pi over lambda. So I'm going to be doing sine 2 pi over lambda into bracket x minus vt. Are we together? Now how can we bring f into the picture? If you recollect, we said 2 pi over time is equals to, okay, that's for angular frequency. Let's just do normal. How does frequency come from velocity? Okay, I think there's a relationship here. F is equals to V is equals to lambda F. Did you remember this relationship? Therefore, F is going to be equals to V over lambda. So we can just make V over lambda to get our F. And to do that, we need to do something. We need to open the bracket with only 1 over lambda, which means I'm going to be having 0.15 sine 2 pi into bracket x times 1 over lambda minus vt times 1 over lambda, which takes into 0.15 sine 2 pi into bracket x over lambda minus v over lambda multiplied by t. Isn't it? Which is the same thing as saying 0.15 sine 2 pi into bracket x over lambda minus v over lambda is f t. Are we together? And we can start putting in the details, which is going to be 0.15 sine 2 pi into bracket x over lambda is 0.01 minus 550 t. Now, what's the LCM of this and 1? The LCM is going to be 0.15 sine 2 pi. Watch this. Into the LCM of this is 0.01. X 0.01 divided by 0.01 is 1 times x is x. 0.01 divided by 1 is 0.01 times 550 gives us 5.5 t. Are we together? Now we can factor the 0.01 outside, and I'm going to be having 0.15 sine 2 pi over 0.01 into brackets x minus 5.5 t. Are we together? 0.01 gives us 200. So I'm going to be having sine 200 pi into bracket x minus 5.5 t. And I think this is the most simplest answer for my equation. And let's see. 0.15 sine 200 pi. Is there anything with 0.15 sine 200 pi? Okay, this is part. Is that what we have? Yes, this is the correct answer. All right, example 20, they said the equation of a transverse wave along a string is given as 0.3 sine, let's write it down, 0.3 sine, let me see if I can put these pages side by side. 0.3 sine 0.5 minus 50t. 0.5x minus 50t. Is that all? It said y and x are in centimeter. And what else was given? I said find the maximum displacement of particles. The maximum displacement of particles from the equilibrium point is the distance between here and the equilibrium, which is the same thing as the amplitude. So they are basically telling us to look for the amplitude. Based on this question, now this looks exactly like a sine kx minus, okay, it looks very close to a sine k into bracket x minus vt k into bracket x minus vt. But this is not exactly it because there is no k here. So we have to try and put this equation in something similar to this form. So I have a sine, watch this, 2 pi over lambda x, 2 pi over lambda into brackets x minus vt. And let me use this whole thing to open the brackets because there was nothing at this point. So I'm going to be having a sine, watch this, 2 pi x over lambda minus 2 pi vt over lambda. We are going somewhere. If you recall, we said v over lambda is equals to f, right? Therefore, I could say the same thing as saying a sine 2 pi x over lambda, watch this, minus 2 pi ft over lambda. No, go 2 pi ft, that's all we are going to be having. Yeah. Therefore, this is now looking very similar, a being 0.3, 2 pi over lambda being 0.5, and 2 pi f being 50. So now we can now compare this equation and this equation now because now they look similar. Therefore, by comparing, we should be able to deduce that the amplitude has to be what? 0.3. Let's confirm. Where's the question I will just solve now? Okay, this is it. So the amplitude has to be 0.3, option D. And yes, the answer is 0.3. Yeah, let's go on to the next question. It said a wave is represented by the equation. So let's take down the equation of the wave. Y is equals to 2 sine 0.5x, 2 sine 0.5x minus 200t, where all distances are measured in centimeters and time in second. Okay? They said calculate the frequency, wavelength, and speed. First find frequency, then we find wavelength, then we are going to be finding velocity, which is speed. So let's try and find the frequency first. This looks like, let's start from the normal equation of the wave. A sine k into bracket x minus vt. Remember this equation, right? But look at it, there is nothing in front of the sign. So let's try and push the k inside. I'm going to be writing a sine, open bracket, kx minus kvt. So let's substitute all the k's. You're going to be having a sine. Recall that k is 2 pi over lambda. So I'm going to be having 2 pi over lambda x minus 2 pi over lambda vt. We are going somewhere, isn't it? Remember that v over lambda is v over lambda is frequency. Therefore, this becomes a sine 2 pi x over lambda minus 2 pi ft. Are we good? Now look at this. This equation looks very similar to this equation. A sine, nothing in front of the sign. Something x minus something t. So I could say by comparing, which equation am I comparing? This and this. I could deduce that by comparing, the amplitude is equals to 2, right? 2 pi over lambda is equals to 0.5. 2 pi over lambda is equals to 0.5. Therefore, cross multiply, I could say 2 pi equals to 0.5 lambda, right? Because we are still asked to find lambda, let me make lambda out of the formula. I'm going to be having lambda is equals to 2 pi over 0.5. 2 divided by 0.5, it gives us 4. So I'm going to be having lambda is equals to 4 pi. So we have found lambda first. All together. In case you did not understand, take it little by little. So by comparing, a was equals to 2. 2 pi over lambda was equals to 0.5. So we cross multiply. I'm going to be having 0.5 lambda is equals to 2 pi. Then divide both sides by 0.5 for lambda to stay alone. Very, very good. So therefore, lambda is going to be equals to 4 pi. That is gotten out. What does it ask us to find? Frequency. Now come back here. If 2 pi, see, by comparing, we know that 2 pi f, see it here, this 2 pi f has to be equal to this 200. Just by comparing. Now, therefore, f is going to be equals to 200 divided by 2 pi, which is going to be equals to what? Shit, why is my system doing this nonsense? Which is going to be equals to 100 over pi. So this is the frequency, 100 over pi. 100 over pi radian or hertz. And what's the last thing they say we should find? Velocity. V. Recall that V is equals to lambda f. Therefore, V is going to be equals to 4 pi times 100 over pi. Pi cancels pi, and V is equals to 400 meter per second. But it told us that all the units are in centimeter and in second. So we have to calculate this meter per second back into centimeter. So 400 meter per second is something as saying, can we convert meter to centimeter? To convert meter to centimeter, multiply by 100, and I'm going to be having 400 times 100 centimeter per second, which is 4 times 10 raised to the power 4 centimeter per second.